Hey guys, welcome back. So today in this video we will be learning on Boolean algebra. Seeing on Boolean algebra. So Boolean algebra is nothing but it's a binary number system, and in this where the system or the equation can have only one of the two possibilities, that is nothing but true or false. So true nothing but 1 and false nothing but 0. So it has only two possibilities, which is true or false. So while performing this Boolean algebra, we'll come across something called truth table, and also we'll see the logic operators in Boolean algebra. So the three logic operators are: one is AND operator, second OR operator, third is NOT operator. So we will see the symbols and the truth table for these operators. Let's begin with first one, which is AND operator. AND operator performs an important operation that is known as logical multiplication. So AND operator performs the multiplication, which is also denoted with a dot symbol. So now we'll look into these rules. For example, I take A and B. So go with 4 records. So not 0 1. So first let's go with 0 0, 0 1, 1 0, 1 1. So this is nothing but a logical multiplication operator. So multiplication denotes that if both are true, then only the result will be true. So let's take R as the result. So if we see here, 0 multiplied 0, it will be 0, 0 1, it will be 0, 1 0, it will be 0, 1 1, it will be 1. So here the AND operation rule is that if both the conditions satisfies as true, then only the result will be true. If either of these conditions satisfies false, then the result will be false. This is the logic of the AND operator. Now let's look into the truth table. Table will also reflect in the same way. So if we just look at the rules, like if we keep it as 0 into 0 is equal to 0, 0 into 1 is equal to 0, 1 into 0 is equal to 0, 1 into 1 equal to 1. So this is just the rules, and this will define your truth table. So this is the AND operator. AND operator nothing but the multiplication. Now let's look into the OR operator. OR operator. Now OR operator will perform the logical addition. So and it denotes with the symbol plus. Let's look into the rules. So the rules here is if 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. So here, so if it is a logical AND operation, here the logic behind OR operator is if either of the condition is true, then your result would be true. So here it is not satisfying with any condition, so result false. Here 0 plus 1, so it's satisfying one condition, so which is true, so it will be true. Here also 1 plus 0, so 1 is true, so it will satisfy the condition. 1 plus 1, again it will satisfy the condition. So this is the rules. And if we look at the truth table, so just keep x, y, 0 0, 0 1, 1 0, 1 1. Result would be same. So 0, 1, 1 and 1. So this is OR operator. Now let's look into the NOT operator. NOT operator. So NOT operator is nothing but it is a single variable. It is a single variable, and operations performed by NOT operator is called as complement. Complementation or complement. So for example, it is saying a single variable. So if you have x, so x complement will be x bar. If you are having y, y complement will be y bar. So this is a NOT operator. So let's look into the rules. 0 complement. 0 complement is nothing but 1. 1's complement is nothing but 0. So the truth table, look, x and y, so 0 and 1, so x complement, so just one table, x complement, 0 complement will be 1, 1's complement will be 0. So this is our NOT operator. So just sum up with a quick review. So AND operator is nothing but a multiplication, and which is representing by dot. So in multiplication, both the conditions should satisfy, then only our result will get a true. Coming to OR operator is nothing but an addition, which symbolized with plus symbol. In this, either any one of the conditions satisfied, then the result will be true. Coming to NOT operator is a single variable, which is also known as complement. So if it is 0 complement, the result would be 1. If it is 1 complement, the result would be 0. Let's see one example of Boolean expression using truth table. So Boolean expression using truth table, we'll see an example. So for example, if I have x plus y dot z plus z complement to this one holds complement. So now we need to derive this in a truth table using whatever just we learned, these operators. So here we have y and z, x, y and z. So let's form x, y and z table. So a very simple thing to remember these zeros and ones. So you can just remember 8, 4, 2, 1. So it means that if you're having 4 variables, so you can follow this, and if you're having 3 variables, you can just follow this one. So 4, 2, 1, meaning that 1, 2, 3, 4. 4 zeros and then 4 ones. Now 2 is like 2 zeros and then 2 ones. So the simplest way to remember and to make a truth table with this expression. Now 1 meaning 1 0 and 1 1. So 0 1 0 1 0 1. So now this has been framed. Now let's try to solve this one. So this is x, y, z. So first let's find out y dot z. So y dot z. So dot is nothing but a multiplication and stating AND operator. So y and z, AND operator means both the conditions should satisfy, then only our result will be 1. So here it is 0 0, so result 0. 0 1, it will be 0. 1 0, it will be 0. So 1 1, so both the conditions satisfy. So 1, here again 0 0 0. Now the condition satisfied, 1. Now let's move into our next column. So next we will be finding out x z the whole bar. So x z the whole bar is nothing but the complement of these x dot z. So x dot z complement. So 0 complement is 1. 0 complement 1. 0 complement 1. 1's complement 0. 0 complement 1. 1 1 and 0. So we found this. Now let's move on this. Now the step is like x plus y dot z complement. So in this equation, let's omit this. We'll look into further with like higher complex expressions. So first expression we'll just look in a simple form. Now it's x plus y dot z complement. So y dot z complement we have already found out here. So x plus. So now x plus this y dot z complement. So plus is nothing but a addition. So either of the condition satisfies, then the result will be 1. So 0 1, the result is 1. 0 1 1 0 1 1 0 0 doesn't satisfy. 1 1 1 1 1 1 1 and 1 1 1 and 0 1. So this is the expressions we have derived with a truth table. So if you want even to add this expression, then this one plus the z complements we can have it, and then we can add on with this expression as well. But for now, let's look into the simplest with this expression. So this is the Boolean algebra. In further videos, we will be learning even more expressions and the logic gates and all those things. This is like we have seen with the 3 variables of these Boolean expressions. Now let's look into the 2 variables. So this Boolean algebra, we need to derive a truth table for this equation, like x plus y complement is equal to y, we just give these complements, So now we need to, so we have x and y. So x and y were just 2. So we can have 2 zeros, 1 1, 0 1, 0 1. So this is our equation. Now let's derive for these Boolean algebraic equations in truth table. So first is x plus y. Let's take it, x plus y. So plus is nothing but an addition which should have a satisfying any one of the condition. So 0 1 1 1. Now let's look into x plus y complement. So nothing but x plus y is complement. So 0 is nothing but 1, 1 is 0, 1 is 0, 1 is 0. Now let's look y complement. So x complement. So x complement 0 1 0 1, 1 will be 0, 1 will be 0. Now let's have y complement. So y complement 0 would be 1 1 0 0 1 1 0. Now x complement into y complement into y complement. So into is nothing but both the condition should be satisfied. So both the conditions satisfied, 1 not satisfying, no, no. So this is how you derive a Boolean expressions using a truth table. So using 3 variables and this is using 2 variables. So in future videos we will be seeing a lot of expressions deriving it. So thank you for watching this video. Please subscribe, like and share.